bit about the work that you do with wildfires.
Okay, so mostly of my work is focused in China. It's about the agriculture fires in China. So what happened in China is after harvesting, those farmers have really short time to get rid of the previous crop residue, and they have to replant the next round. So during the shortest time, the quickest way they can get rid of those crop residue is to burn them, which obviously each individual fire is very smaller, but when you add up together, because China is a very big agriculture country, and it could become like massive fires. So it will become a regional question, and it impact when the wind direction is right. It can impact on the bigger cities, for example, Beijing and Shanghai, which air pollution already exists and pretty bad already.
So tell me about the map here. What is it showing? What can we see?
Yeah, so this map here is to show a general distribution of how the fire occurring in China. So you can see in here around the eastern China is most serious burning area, which is exactly also most people in China where they are living. So for example, here's Beijing, here's Shanghai. So when the wind during summer, during the harvest season, the wind normally blow from the north to the south. So it's exactly blowing into those cities and cause lots of concern and issues there. Yeah.
And are most of the fires in China agricultural fires, or are there some wildfires as well? How much of it is man-made?
So for obviously all the agriculture fires is man-made fires, and in China most of the fires are agriculture fires. There are some grassland fires, maybe in like Inner Mongolia or northeastern China have some forest fires, but that's quite limited compared to how many there are more agriculture fires going on.
So humans are lighting these fires, but presumably the smoke that comes off them must damage human health. How much of a health hazard is it?
It's happening very seasonally. Like for example, every year there are during summer after harvesting, and during autumn there's another around the harvesting. So after harvesting 2 weeks after that, it's an intensive burning season. So 4 weeks in total around the year. It's not a very long term. But for the short term, it's obviously it has some impact on human health, because the local PM 2.5 can goes up to like 3-4 times higher, even it's like 100 or several hundred miles away from where it burns. What is more extreme is it will make the visibility decrease very quickly. So for example, some farmers burn those crop residue just next to highway. It will cause really serious accident when the visibility is really bad in those areas. Yeah.
And tell me about your work and your results. So you were measuring in the field and looking at satellite data. What was the outcome of your research?
Yeah, so this kind of agriculture fires used to be an issue in remote sensing study because they are very small. The traditional sensor we're using called MODIS, it's not capable to detect such small fires. So a few years ago, there was a new sensor available called VIRS. It is very high resolution. It can detect theoretically fires down to 5 to 10 meters square. So it's very suitable for this kind of small fires. So what I have done basically is we combine VIRS data with some validation, some ground-based in-situ measurements together, and we created this kind of new data set, the emission data set, which is available here. So through 4 years, and here is to show the results of the very nice seasonal pattern and the area distribution in eastern China. So we know where those fires come from and how much it has emitted. Like in the our very first results, it shows every year it can produce like millions of tons of carbon dioxide and thousands of tons of PM 2.5. Which is quite a large number in such a short period. And also it compares the result to what it's already exists, some product here like we call GFAS and GFAD. It's what people normally use. You can say it's has a issue of underestimated those emissions quite badly.
So we can see here, so this is 3 years along the bottom, and it's the same time of year, there's a spike at the same time of year, but the spikes are different, because that spike's hardly there, so the spikes are different in different years. So can you now begin to predict that, or are you just measuring the outputs of those fires?
For now, we're just measuring it, because this kind of agriculture fires, as you can see, is quite low here, because that year the government had spent a lot of resource to try to reduce this kind of burning. So you can see it quite effective on what we measure from the space. But I would say it's not that easy to predict whether they will burn it or not, because it's very pure man-made activity.
But you can see here, so on your map at the top here, you can see very clearly exactly where everything is happening, and there's a very short spike and then it all dies away. So you've got all the detail that would allow policymakers to take action if they wanted to.
Yes, exactly. So from this map, they can go down to which village, which field this fire has just occurred, and if they want to do any regulations, say they want to focus more on certain area, then it's all available.